In September 1982, United Airlines operated the first commercial flight of a brand new Boeing wide-body aircraft from Chicago to Denver. The aircraft was the Boeing 767, a twin-engine jet that seated roughly 200 passengers, depending on the configuration, in a fuselage just 198 inches wide. It was, by the standards of its era, a compromise. Too small to compete with the 747 on high-density routes, too large to replace narrowbodies on domestic hops. Engineers called it the middle child because it sat awkwardly between Boeing's glamorous flagships and its profitable workhorses. Nobody expected it to last. The 747 was the icon, the 737 was the moneymaker, the 767 was supposed to fill a temporary gap in airline fleets until something better came along. For over 4 decades since, something better has never quite arrived. In 2026, Boeing continues to build the 767 at its Everett, Washington factory, not for airlines, not for passengers. The last passenger variant rolled off the line in 2017. Today, the 767 exists solely as a purpose-built freighter for FedEx and UPS, and as a military aerial refueling tanker designated the KC-46 Pegasus for the United States Air Force. Boeing has delivered over 1,300 of these aircraft to 74 customers worldwide. Production is scheduled to end for the commercial freighter variant in 2027, but the military tanker line will keep building into the mid-2030s, and the airframes already in service could fly until the 2090s. The 767 is objectively obsolete. Its engines burn more fuel than modern alternatives. Its airframe predates composite construction by decades. International emissions regulations will effectively ban new-build 767s from operating outside the United States after 2028, even if Boeing has received an exemption. Yet, FedEx operates 150 of them, UPS operates 102, Delta and United still fly passenger versions across the Atlantic. So, how can an aircraft from 1982, one that will fail modern emissions standards once they come into effect and burns more fuel than modern widebodies, remain so thoroughly irreplaceable that the entire global logistics network depends on it? To understand why the 767 refuses to die, we need to understand the specific problem it was designed to solve, and why that problem never went away. In the late 1970s, Boeing identified a gap in the commercial aviation market. Airlines needed an aircraft that could carry 200 to 250 passengers over medium to long-range distances of 3,000 to 5,000 nautical miles. The 747 was magnificent, but absurdly expensive to operate on thinner routes. Narrowbodies like the 727 lacked range. The DC-10 and L-1011 required 3 engines, adding fuel cost and maintenance complexity. Boeing's answer was 2 aircraft developed simultaneously, the narrowbody 757 for high-demand domestic routes in the US, and the widebody 767 for everything in between. The 767 launched on July 14, 1978, with an initial order of 30 aircraft from United Airlines. But the aircraft's most transformative contribution came not from its passenger cabin, but from a regulatory revolution it helped create. Before 1985, twin-engine aircraft were restricted from flying more than 90 minutes from a sustainable diversion airport. This effectively banned them from crossing oceans. 3- and 4-engine jets monopolized transatlantic flying. Then, the 767 proved something radical. Its engines, specifically the GE CF6 and Pratt & Whitney JT9D, demonstrated such extraordinary reliability that the FAA progressively extended the diversion limit, first from 120 minutes in 1985, then to 180 minutes in 1989. On February 1, 1985, TWA operated the first ETOPS qualified transatlantic crossing using a 767 from Boston to Paris. By the year 2000, the 767 was the dominant aircraft on many transatlantic routes. The aircraft didn't just fill a gap, it destroyed the economic rationale for 3- and 4-engine widebodies on medium-haul international routes. It made twin-engine oceanic flying the global standard. Airlines adapted their entire fleet strategies around the 767's unique combination of range, passenger capacity, and operating economics. The 767's fuselage is 198 inches wide. This single measurement explains nearly everything about why the aircraft cannot be replaced. In passenger configuration, 198 inches allows for a 232 seating layout in economy class, 7 seats across. This means only 1 in every 7 passengers occupies a middle seat. Compare that to the 787's 333 layout or the 777's notorious 343. Passengers love the 767. But the 198-inch cross-section matters even more below the passenger cabin and inside the freighter variant. The 767's fuselage was designed to accommodate LD2 unit load device containers in its lower cargo hold. These standardized aluminum containers are the backbone of air freight logistics. The 767-300F, the purpose-built freighter variant, launched in January 1993 following an order from UPS, can carry 24 standard main deck pallets measuring 88 by 125 inches, plus additional LD2 or LD3 containers in the lower holds. Total cargo volume reaches 438 cubic meters. Here's the critical detail. The 767's cargo cross-section fits ULD configurations with almost zero wasted space. The containers nest against the fuselage walls with remarkable geometric efficiency. This isn't an accident. Boeing designed the 767's diameter specifically around these standard container dimensions. The A330, by comparison, has a wider fuselage at 222 inches. This sounds like an advantage until you realize that the extra width doesn't translate into additional ULD positions. It translates into wasted volume across the fuselage walls, where containers can't fill the space efficiently. The 787 Dreamliner presents an entirely different problem. Its fuselage is built from carbon fiber composite. Cutting a massive main deck cargo door into a composite barrel is an unproven engineering challenge of enormous complexity compared to cutting into the 767's traditional aluminum semi-monocoque structure. Boeing has explored a 787 factory freighter concept, but the engineering remains daunting and the timeline keeps slipping. However, Airbus is developing a purpose-built freighter based on an aircraft whose fuselage is primarily made of composites, the A350F. The type should make its commercial debut sometime in 2027. The 767 sits in a category of 1, and no manufacturer has built anything to occupy that category after it. The term zombie aircraft describes an airframe that persists not because it's optimal or modern, but because the gap it fills has no alternative. The 767 is the definitive example. When Boeing launched the 767-300F in 1993, the express cargo market was a fraction of its current size. UPS took the first delivery in October 1995. FedEx followed. As of early 2026, Boeing has delivered 271 factory-built 767-300 freighters. But factory-built freighters represent only part of the story. The far larger economic engine is passenger-to-freighter conversion. Companies have converted hundreds of retired passenger 767-300ERs into freighters. The conversion costs approximately tens of millions of dollars, yet is still cheaper than converting an A330 CEO. When you factor in the acquisition cost of a used passenger 767, an operator can put a wide-body freighter into service for much less than purchasing a factory-built 767F. A new-build 767-300F costs around $200 million at list price. A new 777F exceeds $300 million. For integrated logistics carriers like FedEx and UPS, the economics are overwhelming. These operators don't fly their freighters the way passenger airlines fly their jets. Cargo aircraft operate primarily at night, flying hub-to-hub routes timed around next-day delivery guarantees. They accumulate fewer cycles per day than passenger aircraft. The older, less fuel-efficient CF6 engines don't penalize operators as severely in this operational pattern because the flights are shorter and utilization rates are lower. Fleet commonality amplifies the advantage. When FedEx operates 150 Boeing 767's and UPS operates 102, every additional 767 reduces per-unit training costs, maintenance costs, spare parts inventory, and simulator requirements. Pilots certified on the 767 can also fly the 757 under a common type rating. The entire operational ecosystem orbits around this single airframe. This is why UPS has continued to order new 767s, even as the aircraft approached its fifth decade of production. The alternative isn't a better aircraft. The alternative is no aircraft at all. The significance of the 767's survival isn't really about FedEx or UPS, and it isn't about cargo efficiency. It's about what a single military contract did to Boeing's entire defense decision, and why the company can't walk away despite losing over $8 billion. In February 2011, the US Air Force selected a modified 767-200ER, designated the 767-2C, as the basis for the KC-46A Pegasus aerial refueling tanker. The KC-46 was meant to replace the ancient KC-135 Stratotanker, of which approximately 376 remain in service, some dating back to the late 1950s. To win the contract against a rival Airbus A330-based bid, Boeing priced the KC-46 using a fixed-price development contract. This meant Boeing, not the Pentagon, absorbed any cost overruns. The decision proved catastrophic. The remote vision system, the camera system used by boom operators to guide fuel transfers to trailing aircraft, suffered from distortion and lighting failures under certain solar angles. Boeing redesigned the entire system at its own expense. In March 2024, deliveries halted due to broken gimbal nut lock wires on refueling booms. In early 2025, Boeing stopped all deliveries after discovering structural cracks in newly built airframes rolling off the Everett line. In the fourth quarter of 2025 alone, Boeing recorded a $565 million charge against the KC-46 program. CEO Kelly Ortberg described it bluntly during an earnings call. "This has been a bad contract for the last decade." CFO Jay Malave attributed the losses to rising supply chain costs, factory rework, and the inherent inefficiency of producing the underlying 767 airframe at low production rates. Boeing currently maintains 77 KC-46 orders, with 67 for the US Air Force, 4 for Israel, and 6 units for an unidentified customer. Boeing has delivered 112 as of March 2026. Boeing cannot cancel the KC-46. The US Air Force's tanker fleet is a cornerstone of American global power projection. Walking away would hand the tanker market entirely to Airbus, whose A330 MRTT has already secured 85 orders from allied nations, with 66 delivered. The Everett production line must keep running. And because the KC-46 shares the 767 airframe, the tooling, workforce, and supplier networks that support the commercial 767-300F freighter simultaneously support the military tanker. The two programs are economically inseparable. When 33,000 Boeing machinists from IAM District 751 went on a strike for 53 days in 2024, production of both the freighter and tanker halted simultaneously. FedEx, UPS, and the US Air Force all waited. The most pressing threat to the 767 isn't a competitor, it's the calendar. In 2017, the International Civil Aviation Organization adopted stringent greenhouse gas and noise emission standards designed to force manufacturers toward cleaner technologies. The FAA adopted these rules in 2022. Because the 767 uses 1970s-era aerodynamics and older generation engines, it fundamentally cannot comply. The regulations prohibit the production of non-compliant aircraft after January 1, 2028. For international operators, that deadline is absolute. Any 767-300F built after December 31, 2027 cannot legally operate outside the United States. But domestically, a different timeline applies. In May 2024, the US Congress passed the FAA Reauthorization Act, which contained a legislative carve-out heavily lobbied for by Boeing, FedEx, and UPS. This section granted a 5-year exemption from emission standards for purpose-built freighters with a maximum takeoff weight between 180,000 and 240,000 kilograms. The 767-300F, with a maximum takeoff weight of 186,880 kilograms, fits this description perfectly. The exemption extends domestic production eligibility until January 1, 2033. However, Boeing confirmed that the final commercial 767-300F will still roll off the Everett line in 2027. The international restrictions make continued production economically unviable for globally operating freight carriers. After 2027, the 767 line shifts exclusively to K6-46 tanker production, which is exempt from commercial emission standards under military provisions. This means the 767 freighter fleet becomes a finite, depreciating asset. No new ones will be built. Conversion feedstock from retired passenger 767s is dwindling as the aircraft age out. Every 767 freighter in service becomes incrementally more valuable as the population shrinks. FedEx and UPS face a slow-motion crisis. Their fleets of 767s will continue operating for 15 to 20 more years, but there is no like-for-like replacement waiting. The 787 freighter concept is only a theory. The A350F is too large for medium-haul express routes. The 777-8F targets the heavy long-haul segment, not the medium-haul domestic market where the 767 dominates. The middle of the market is becoming a void. Richard Abulafia, the prominent aerospace analyst at Aerodynamic Advisory, has spent years criticizing Boeing's failure to develop a new mid-sized airplane, often called the 797, to replace the 757 and 767 simultaneously. In 2022, he summarized the industry's frustration with devastating precision. The possibility of disruptive new technologies has provided a useful excuse for Boeing to do nothing. In the meantime, the middle market is the hottest segment the industry has seen in decades, and it now belongs to Airbus. The A321neo has already consumed the 757's territory entirely, but for the 767's cargo role, even Airbus has no answer. The A330 targets a different segment. The middle-of-the-market freighter niche remains unoccupied. Boeing's internal product development teams were reportedly working on the 787 factory freighter, but delivery timelines, if confirmed, could stretch to mid-2030s. Even if it materializes, operators like FedEx and UPS would face enormous transition costs in training, maintenance infrastructure, and fleet logistics. The economic gravity of fleet commonality means that switching away from the 767 is almost as expensive as continuing to operate it. Delta and United still fly passenger 767s across the Atlantic, not because they want to, but because delivery backlogs and fleet planning constraints leave them no alternative. Pilots praise the aircraft's reliability and its remarkably roomy cockpit compared to the 757. Passengers appreciate the 232 layout. The 767 persists not through excellence, but through the absence of anything else that does exactly what it does. By every modern metric, the Boeing 767 is a relic. Its aluminium fuselage adds weight. Its engine consumes more fuel per seat mile than any current generation alternative. Its cockpit design predates glass displays. Yet, the global economy depends on it. The 767 doesn't represent Boeing's best engineering. It represents something more uncomfortable. It represents a market failure. Boeing never built the replacement. Airbus never built the alternative. The regulatory framework is forcing an aircraft out of production before any manufacturer has created a successor that matches its unique combination of fuselage cross-section, wingspan compactness, cargo geometry, and conversion economics. The production line at Everett will shift to tankers only after 2027. The existing freighter fleet will fly for 2 more decades. The KC-46 program may keep the 767 airframe in production into the mid-2030s. And if those tankers serve as long as the KC-135s they're replacing, the 767 could remain in active military service until the 2090s. The question isn't whether the Boeing 767 will eventually disappear. Everything does. It's whether the industry will actually build its replacement before the last one falls apart.